Qwen has promised an open-weight 27 billion parameter model. That could matter on local hardware, except there's nothing to download or benchmark. 27 billion parameters sits in the size class local builders can measure, quantize, and run without pretending a data center is a laptop. The announcement confirms the name and open-weight intent. It does not reveal architecture, license, context, quantization, or independent results for the 27 billion model. So the useful question isn't whether the headline sounds exciting, it's what evidence must appear before frontier on a laptop becomes testable. Qwen's August 3rd announcement said Qwen 3.8 max open weights would arrive the following week, and Qwen 3.8 27 billion would also go open weight. As checked on August 8th, Qwen's official model listing exposed no downloadable Qwen 3.8 27 billion checkpoint, so local testing still had no official starting file. Open weights are a release promise. A checkpoint is the artifact you can load. Right now, the promise is confirmed and the artifact is absent. That gap is the whole episode. What's real, what's merely adjacent evidence, and what your hardware should measure when the model finally lands. The safest reading is narrow. Qwen named Qwen 3.8 27 billion and said it is going open weight. Everything beyond that needs another source or a test. Open weights is the release wording Qwen used. It still does not answer the 27 billion license terms, file formats, or runtime support. We don't know whether Qwen 3.8 27 billion is dense, sparse, multimodal, or something else, because no official architecture table accompanies the announcement. We also don't know the 27 billion license. Until the checkpoint exposes one, local availability and commercial permission remain separate questions. The hosted max model lists 1 million tokens of context, but official documentation still gives no context specification for Qwen 3.8 27 billion. No official 27 billion quantization support is documented yet. That means GGUF files, loader compatibility, and quality at lower precision are all unverified. There are no independent Qwen 3.8 27 billion results in the packet, so every performance comparison today is prediction, not proof. Those blanks aren't disappointing trivia. They define exactly what builders must inspect next, instead of reverse engineering certainty from one announcement. Start with the announced 27 billion count, multiply it by storage per parameter, and you get a transparent raw weight estimate. At 16 bits per parameter, 27 billion raw weights equal roughly 54 gigabytes, before runtime overhead and the context cache. At 8 bits, the same arithmetic becomes roughly 27 gigabytes of raw weights. That still excludes loader overhead and any cache. At 4 bits, 27 billion raw weights equal about 13.5 gigabytes. That's the attractive laptop number before everything else arrives. Raw weight arithmetic excludes runtime overhead and context memory. The verified packet supplies no Qwen 3.8 27 billion values for either part. Max documents 1 million tokens, while Qwen 3.5 27 billion documents 262,144 native tokens. Qwen 3.82 27 billion still has no official context figure. Whether the model fits depends on quantized weights, runtime overhead, cache size, and your actual memory pool, not parameter count alone. Until real files exist, treat 13.5 to 54 gigabytes as raw weight arithmetic across 4 to 16 bits, not a compatibility chart. The arithmetic explains why builders care. It cannot tell us speed, output quality, context behavior, or whether today's local tools will load the model. QwenCloud lists Qwen 3.8 Max as its flagship text generation model. That gives us a real product surface, but not the smaller model's specifications. Official QwenCloud documentation lists a 1 million token context window for Qwen 3.8 Max. It does not assign that number to Qwen 3.8 27 billion. QwenCloud also marks function calling for Qwen 3.8 Max, meaning the hosted model can request structured tool actions through an agent harness. A harness is the surrounding agent software that routes model requests to tools and returns results. Qwen Code is one documented example here. Qwen's developer documentation shows Qwen 3.8 Max inside an agentic Qwen Code workflow that analyzes a task and implements a cover generation skill. That example also says Max lacked multimodal capability, so Qwen Code routed image understanding to a configured vision model before Max continued. That's useful evidence about Qwen's agent system direction. It also proves why a polished workflow cannot isolate the capability of one unreleased model. Max shows Qwen's current priorities: long context, reasoning, tools, structured output, and agent workflows. The 27 billion feature set remains unconfirmed. Qwen 3.5-27 billion is the nearest official size class baseline in the packet. It helps frame precedent, not predict the new model's internals. Its official model card describes Qwen 3.5-27 billion as a dense 27 billion parameter model with a vision encoder. That description stops at version 3.5. Nothing in the verified packet says Qwen 3.8-27 billion keeps that dense multimodal design, so carrying it forward would be invention, not inference. Qwen 3.5-27 billion lists 262,144 native context tokens and extension to roughly 1 million. Those figures belong only to the older model. A previous generation's context length cannot fill the new model's blank spec. Similar names and equal parameter counts are not compatibility guarantees. The Qwen 3.5-27 billion page links quantizations for llama.cpp, llama, LM Studio, and compatible applications. That proves precedent for local packaging, nothing more. The older release shows Qwen has already packaged a 27 billion model for local ecosystems. It cannot guarantee the same path for Qwen 3.8. Use Qwen 3.5-27 billion to ask better questions about memory, context, vision, and loaders, not to pre-answer them for Qwen 3.8-27 billion. Release day starts with the official checkpoint and model card, not a screenshot, repost, or community file name that merely looks plausible. Read the published license before commercial use. Open weight availability tells you access exists. The license tells you what permission actually travels with it. Find the architecture table before estimating performance. Qwen 3.5-27 billion is documented as dense, while Qwen 3.8-27 billion's architecture remains unknown. Look for native context, not only an extension claim. Then test memory growth and retrieval quality at the lengths you actually use. If the model card lists vision, test it directly. Don't infer multimodality from Qwen 3.5 or from a Qwen Code workflow that routed vision elsewhere. For agents, verify the model emits valid tool requests repeatedly, not just once in a polished example. Reliability lives across many calls. Inspect which quantizations actually exist, who produced them, and whether your loader recognizes the format before planning around 4-bit arithmetic. Record memory at model load before sending a prompt. That isolates the checkpoint and runtime cost from the growing context cache. Time prompt ingestion separately from generated tokens. A model can answer quickly after spending a long time reading your repository. Then measure generated tokens per second after warm-up. Report the quantization, runtime, hardware, and context length beside the result. Increase context gradually while watching memory, prompt speed, and retrieval accuracy. A maximum length is less useful than behavior along the way. Run the same agent task with and without routing helpers. That separates model behavior from gains supplied by tools, vision models, or orchestration. Save prompts, files, settings, and outputs. If another builder cannot repeat the test, a dramatic score is content, not dependable evidence. Any closed model comparison needs matched prompts, tools, context, and scoring. Otherwise, you're comparing entire systems while naming only the models. Only after license, architecture, files, memory, speed, context, and agent reliability are documented, does Frontier on a laptop become a serious claim. Qwen 3.827 billion could become an important local release because the size is relevant and the open weight intent is official. Could is doing essential work. We can say Qwen promised the model. The 27 billion class has local precedent, and raw low-bit weight math reaches laptop-relevant territory. We cannot honestly claim the model matches a closed frontier system, fits a specific laptop, supports vision, or runs well in today's loaders. The first meaningful update is the official checkpoint and model card. Those two artifacts can replace most speculation with inspectable facts. Next, watch for verified quantized files and loader support, because local usefulness begins when the artifact survives real software and memory limits. The decisive evidence will be repeatable local results for memory, prompt processing, generation speed, long context, coding tasks, and tool reliability. Today, Frontier on a laptop is a compelling test question, not a result. The announcement earns attention. Only released evidence can earn the verdict. When the checkpoint lands, test the file, not the aura. Subscribe if you want the measured local verdict instead of another launch day guess.